So for today, think of your network as a live band. Every server, app, and device is an instrument. Now, when they're all in tune or in key, you get harmony. But when one is out of sync, you hear the feedback, the missed notes, and the silence where sound should be. And today's hybrid dynamic networks are like massive orchestras spread across multiple stages. You got your on-prem, your cloud, and everywhere in between. It makes me think of back in the COVID days while artists, were recording in their own little studios and combining them into a video. And without the right conductor, it's chaos. So today, my buddy, Plixer data scientist Adam Howarth turns the noise into music. Let's see how top IT teams go beyond basic monitoring to get full visibility and accelerate root cause analysis across every environment. No more blind spots, just clear, synchronized performance. Take it away, Adam.
Awesome. Thank you, Peter. So my name is Adam Howarth, and I work on our data science team here at Plixer. Additionally, I work with a lot of customers around building out workflows and general kind of product familiarity. So I am excited to talk about some of the topics today, root cause analysis, how to really kind of leverage flow. And specifically, I want to get into some of the details around some of the lower level components of flow, how it works. For some people, it may be somewhat remedial. For some people, it may be new information. But it's definitely interesting elements of using NetFlow or IPFIX for network monitoring, visibility, and ultimately kind of, instantaneous troubleshooting. So to begin, we'll really consider kind of like why visibility matters now. This has been a topic of conversation for quite a long time. NetFlow is like 20 years old. But as time has gone on, what we've really run into is we have lots of different sources of truth about the network that can be both on-prem and just traditional flow logs that are coming from our infrastructure, our routers and switches and firewalls at a basic level, kind of the simple 5-tuple, source, destination, source port, destination port, and protocol that we're used to for a network observation. But where these are starting to be sourced from different places, they're often being routed to kind of their own unique views. And before you know it, you kind of end up panning around between, this is where I have visibility into what the distributions layer is doing. This is where I have distribution or visibility rather into kind of firewall auditing or Cloudflow visibility. And ultimately, we end up kind of bouncing around between all these tools. And from a user perspective, it can be inconvenient or annoying, but it's doable. Have several UIs, you kind of get a window next to a window. It's not the best case scenario, but it can certainly get you through. Really, the problem with this comes down to the input domain problem in general. So the input domain in the case of UI is, different tools have the data. So however their view layer is orchestrated is really going to be what you have available for accessing that data. So again, slightly inconvenient from a human perspective, but not kind of a showstopper. Really where this becomes important to consider are the analytics that are running on these platforms. So when you have, the entirety of the network, if it's in a hybrid model, ultimately being observed and reported on at different nodes and different points, you end up with a situation where there might be an algorithm on one platform that's reviewing all of the traffic, looking for, say, a reflective DDoS attack. But another platform considering data from a different segment of the network that might have either a slightly different algorithm or no algorithm at all to consider those problems. So again, it's really kind of parsing through that idea of, multiple UIs, obviously not ideal, but doable. But really at the analytic level, having your input domain fractured means you have separate analytics looking at different data and ultimately coming to different results. So when I think about visibility, the word really implies that we're like looking at stuff. But ideally, it's really this process of providing input data to analytics stacks that can really review the data at the speed at which it's happening. There's a lot of analogies out there between like human reaction time and the speeds that things are actually happening on the network, and they're logarithmically different. So the amount of time it even takes a person to kind of notice something has happened allows for hundreds, if not millions, of network transactions to happen in that same period of time. So really considering the analytics side of your input domain is really important, and making sure that one place that's running analytics against that traffic does have visibility across all of the available input data. So just kind of a high level note to think about as we go into these things. So today we're going to be looking at a few use cases from our field guide. It's basically a large document that kind of breaks down use cases across both NPMD and NDR and how you can apply flow and network observability to solving those problems. So today we'll be looking at root cause analysis, some firewall event auditing, as well as some general network segmentation, and seeing how actually enriching our flow observation data as it's received gives us all sorts of new pivots and opportunities to look at network connections at a business function level, as opposed to just the actual raw entities on the network that are communicating with each other. So I want to start with just a little bit of background on flow. Again, this is the part that might be remedial for some, but I think it's good just to cover and establish a basis. So we'll cover a few items here and then kind of move over into the product and look at what some of these workflows look like. So to start with, a really important concept in flow export and collection and analysis that may often get overlooked, but if you've ever gone through a configuration, especially on a Cisco device where they're very verbose and you have access to all the low-level parameters, this is going to be something you've bumped into or might be familiar with. And that's really the concept of time granularity and the flow observations themselves. So in a traditional flow cache, these are governed by active and inactive cache timeouts. So in this kind of little graphic here, if you imagine times moving to the right, and this is a continuous connection that was established over, say, a router, and this is an entry in its flow cache. If that connection is alive for 150 seconds on a 60-second active timeout, basically what we're going to get is the first minute will be considered a block of information. That active timeout, the conversation's active, so after 60 seconds, we're going to time out that entry, even though it's still active. As soon as an active timeout happens, immediately a new entry is put in the cache for the next minute, because we know that conversation hasn't stopped yet. So between 0 and 60, we get a flow. Between 60 and 120, we get a flow. Between 120 and 150, the flow stops. And then 15 seconds later, at 175 seconds, our inactive timeout happens. So effectively, the inactive timeout is a time buffer that allows the conversation to resume and still be considered the same connection, or ideally find kind of our termination point and send out the final update of data about, in this case, the last 30 seconds that happened, since there wasn't a full minute for the active cache timeout. Where this is a really important concept to consider is this will give us to the minute granularity of the state of these flows, and ultimately allow us to report on sections of time that are in the middle of conversations. So where we can report independently from the start or the conclusion of a conversation. We don't necessarily need to go to the conclusion record and then use like the time bounds that were provided by the exporter to figure out when this was occurring. Instead, we get updates in real time, minute by minute. We get all of our aggregates summarized, and we'll talk about that a little bit later when we talk about the various flow record types and templating. But we get a summary of what was happening at that exact instant in time. So when we go to drill into a report, we'll see later on, we can actually see exactly that moment, as opposed to having to infer anything about it from aggregated data that was supplied around that time. This same idea holds up for firewall events, another component we'll look at in the tool in a moment. So in the case of firewall events, we do still have active and inactive cache timeouts, but we also have NSEL or network secure event logging, which will give us some insight into the events that are happening on the firewall around the inspection queues that are actually looking at the traffic and enforcing your policies, all the way through denials. If you just want quick insight into what is your firewall blocking at the moment, just a quick check to see is this our application problem? Is the firewall's just not allowing the traffic through at all? And ultimately, the delete event when the inspection queue for that traffic is terminated by your firewall, and the final kind of update about what happened is issued. So again, that conversation starts, it's created and slotted into the inspection queue on the device. Every active cache timeout period of time, normally 60 seconds, should be 60 seconds on our platform at least. You'll get an update, which will give you all of the deltas. So you can think packet counts, byte counts for the last minute of that open and active conversation over the firewall. And then ultimately, similar to our inactive timeout in a normal flow cache, when the conversation concludes, an inactive timer will expire, and then ultimately we'll get a delete event representing that conversation has both expired from a reporting standpoint for us, and it's no longer in the inspection queue of the firewall. So it actually gives you a great way, if you're facing CPU issues on a very busy firewall, to get some insight into kind of what actions is it taking, when are those bursts in activity. Maybe there's lots of long-running conversations, but they all start at the same time, so you can get a good idea as to when kind of the inspection queue is being really hammered for new conversations versus just maintaining things that are open and active. So really two timing metrics to keep in mind as we move forward, the active and inactive timeouts, and then ultimately with firewalls, kind of the event-driven timeout activities that will happen. So for additional background, I want to talk about information elements, the things that are actually in our NetFlow records themselves. So if you go all the way back to NetFlow v5, this is a pattern that I think a lot of people are very used to. It was pretty dominant, and it was ultimately what introduced the technology to everyone. And this was a fixed record. So that was in the top, we have our match fields. Match fields, when you're talking about flow, are going to be the static items, the items that when these are present, this is a network conversation that we want to consider an entity. So things like source IP, destination IP, maybe the next hop IP address, ingress interface. If we're applied on ingress monitoring, it would be egress in the case we're applied on egress monitoring. The ports and protocol, and that will ultimately define what our flow is. And then while that flow is open and active in the flow cache, all of our collect fields will actually be determined while the conversation is ongoing. So things like packet delta count, byte delta count are kind of the obvious ones, but TCP flag aggregate, so all of the TCP flags that were observed during that period of time, TOS bits, kind of information that needs to be decided by the device as it's going through, or observed over a period of time, as we saw with the timers in the previous one. Like if we think about TCP flags, the initial SYN is going to come off the client, an ACK will come back, or SYN ACK will come back from the server, an ACK from the client. That all happens in the first minute because it's going to happen very quickly. You get a TCP aggregate of those three flags. Ultimately, with our minute-by-minute quantization of the flow, if some sort of reset starts happening, TCP red starts getting involved, something weird's going on, we actually have that minute-by-minute granularity in order to figure out when those things are occurring, as opposed to just looking at an overall aggregate and saying it did happen, but it's difficult to attribute exactly what time slice those events occurred in. So in this case, again, NetFlow v5, static records, pretty limited in what it can actually export, good information, but still there isn't really any user level control over it. This was kind of the early approach to NetFlow because it was very easy. You could expect the same input from every device, and there was some uniformity by what you could actually expect to be receiving, and not a lot of variability in what the actual information elements, the fields of the NetFlow record could contain. As time moved on, we had NetFlow v9 and then ultimately IPFIX, which is NetFlow version 10. But once we move into these newer versions of flow data, we start getting into templated flow data. So this is something if you're very familiar with flow, you'll know for sure. If you're peripheral to flow, you may have heard. But templating flow data allows these records to be variable and have different types of information in them and in different combinations, and ultimately vendor-specific items too. So things that maybe weren't even considered, when NetFlow was initially proposed, but the technology moved along later down the road, and suddenly we can, use DPI techniques to give an application label to a flow record, and we need an information element to actually store the label for that application in. So with IPFIX, we get this idea of templated flow structures, and then ultimately platforms like the Plixer platform can read in these templates, understand what that device is telling us, and then ultimately at a very high rate parse the data records as they come in, because we don't need all the overhead of the fields defining what the data is. If you think about something like JSON has a field identifier on every value. So when you transport that data, it's automatically significantly larger than it needs to be, just because if we already know what the fields are, then we can just parse that kind of in order against the template and then label those values as they're supposed to be as the template defines. Kind of without that structure, again, you really need those field identifiers over and over and over again. And then ultimately we're in the business of solving, kind of the million flows a second situation where every byte counts. So compressing this input data down and still being able to have a really verbose catalog of elements that you can report on really becomes kind of the main problem of solving, and really what powers the ability to do quick root cause analysis and have really low level granular access to really interesting elements and attributes of your flow that necessarily wouldn't be represented in something like a V5 record. So this is a major part of the platform and a major part of helping use the capabilities that all of our exporting devices, the actual network infrastructure itself, can enrich flow data with. Again, things like usernames. If you're terminating a VPN, you want to actually attribute those flows to a person or a device that can do DPI and tell you exactly what application it's classified as, all the way through things like performance-based metrics. Anyone that joined us for the last webinar, that was what that was all about, was like UDP jitter, kind of figuring out the variance an inter-arrival time between packets. That ultimately needs an information element to deliver those millisecond readings into the platform, and then TCP latency, kind of the same idea. You need some sort of field in the flow record that knows that's a millisecond value and has some understanding of kind of what the quality of the metric actually is. So a platform understanding those information elements and ultimately making them available through reporting and API calls in context of what they actually are meant to represent goes a long way in kind of short-circuiting the troubleshooting workflow by just, again, leveraging what these devices can already do. So again, at a super high level, information elements are very important for kind of advanced NetFlow usage in the sense that multi-vendor support becomes a much simpler situation where you can just platform like we have an enormous library. We have thousands of information elements across basically every vendor you can think of. So we understand what they're going to be exporting. We know how to parse through that and ultimately make it available in a report that you can get some usage out of. So again, performance metrics, vendors might classify applications differently. So there might be a different information element that's associated to their output for those tests. And then ultimately having a knowledge and understanding of all of those allows a passive platform to just start receiving flow data, review the template, go, okay, perfect. We have definitions for all of these kind of exotic information elements that are found in this template, and let's align that with the kind of reporting workflow that makes the most sense for those devices. Again, something we'll see when we pivot into the product in a second. There's a lot of dynamic options that become available specifically around things that are unique to the infrastructure exporting to us. So some of the issues around why I focus on timing and that component of flow when we talk about root cause analysis comes down to what granularity do you actually have to zoom into these conversations. So because of how verbose flow data is, most platforms will actually take your 1 minute or wherever your active cache timeout is in granularity for flow records and then aggregate those up into higher intervals, effectively kind of undoing the benefit of that low-level granularity. It's really more of a storage problem in most cases where a very high level of very verbose records can be difficult to manage and sort through and report on. But that's really where we focus our effort in making the flow data usable for people. It's kind of, we've long been kind of like the nerdy network engineering tool where we do our best to kind of stay out of the way of the data and make sure it's presented to you as it was exported by the devices. So there's really no sense of aggregation where we take 5 individual minutes, turn into a 5-minute interval, delete those 1-minute intervals off, and then just keep this aggregate. It can quickly cause problems where if you think, again, the TCP flag example, in one frame, you only see SYN and ACK flags. Another frame only SYN and ACK flags. In the third frame, we actually see a reset from something, whether it was the application side or network infrastructure, just trying to kind of shuffle connections around through red. Another minute at the 4th minute of just regular SYN ACK, and then ultimately a reset at the end that could have been application driven, right? So when you take something like this and aggregate it into a 5-minute data point, you would really just see kind of a SYN, ACK, and reset with no real sense that there were 2 events there that caused resets or really what the timing was around those other than this kind of blocky 5-minute view. So what we do is we take an approach where we still receive all the 1-minute data. We do make 5-minute aggregates for workflows that do benefit from just a faster reporting experience. Things like top talkers, every time you aggregate things down, the things up at the top aren't really affected. It's more the small conversations that will be impacted. From a security standpoint, that can be a nightmare because it's less likely your top talking application that everyone's using is the problem. It's more likely the very small SSH or telnet session is actually what you want to be aware of, which could just get completely obliterated by that aggregation process. In our case, what we do is we actually store off all of the 1M as it's received, the atomic records exactly as they came off the flow cache from your exporting devices, as well as create aggregates kinds of workflows. So we'll see in the tool where this benefits us, where we can start at very wide time frames, kind of find the instances where maybe bandwidth utilization is spiking, and then ultimately drill into those spikes and then go back into the 1-minute visibility so we can have clear views as to exactly what the traffic was comprised of. One last component that I want to review is the idea of enrichment. Exporting devices, they know everything they know. They're sitting in line, they're handling the traffic, they understand kind of the routing and the general structure of, again, what they have access to depending on their layer of the network. Those are all things they can impute into the flow record and make available for export. But there are still some kind of business level higher items that can help us navigate flow records a little bit easier to understand exactly what their purpose is, or to even start a study from a business function perspective first, and then kind of work our way backwards into the implications as to what network infrastructure or entities using the network could actually be impacted by either a change or a downtime or something along those lines between those two business functions. So what the platform allows us to do is give definitions. In the case of something like IP groups, we can say, this IP address or this subnet or this list of IP addresses belongs to devices for accounting. This other set belongs to like the manufacturing network segment. And then ultimately, rather than reviewing flow data from a purely IP standpoint, we can actually work in these abstracts, look at a department to department flow, and then once we've kind of identified who's talking to who and when, we can then drill back into the low-level views and actually see the kind of the raw flow data that's going to express exactly what entities are involved and what applications are using that link. So with that little bit of background, I do want to jump over into the actual tool itself. When you log in to the Plixer platform, you'll drop into one of these higher level monitor type views. So that can be dashboard views that summarize all sorts of kind of information that you've found useful over time. Anytime really you find a workflow that was helpful, it's kind of always worth saving that off as a data source. And then if it's turned into a dashboard gadget like these, they're both available for high level visibility, as well as they become pivots that take us directly into data. So we'll go back through in a moment through the entire reporting stack as to how we get to these products. But it is always important to kind of keep in mind as you go through that really none of your effort is ever wasted on the platform, because when you find a valuable view that helps you solve a problem, it can always be saved as a data source, turned into something like a dashboard gadget or just a save report for quick access. And then you can just return exactly to that view, maybe make some filter changes for whatever the specific problem is at the moment. And again, give you just kind of a nice jump off point where there's an expected quantity and quality of data that you can rely on in the moment when an investigation or application degradation is happening in real time. Again, this kind of brings us right from the finished product into a report. But if we start back at the beginning, we can see we have a few different ways of accessing data. So reports come in, there's some issue, maybe on like a WAN side link at a site. We can start from an interface perspective where we have a view of all of our interfaces that are reporting into the product. The flow caches that we talked about in the previous step, when they're actually turned into flow monitors for actively collecting things that are happening, they get applied at an interface level. We not only have all of our exporting devices, so the actual network infrastructure as a whole exporting to us, but the visibility is broken down on a per interface basis as to where those flow monitors are applied. What this ultimately allows us to do is get great views into per interface network observations. So we don't have to rely on, this device did this in aggregate or whatever. We can actually drop down to just the physical interfaces, or virtual. So I guess that's a bad choice of words, but the actual point that's handling the traffic, and see exactly what the state of it was at that point in time. So if there's any sort of transformation happening in a traffic flow, maybe an application was configured for like EF DSCP, thinks it's the highest priority because it's some sort of real-time application, but the network really isn't prioritizing those things. Maybe the application at the first hop said, like, I'm definitely an EF packet. Please let me skip the queue and push me through right away. If that device has a different classification schema on it, it maybe makes an augment to that class of service marking. And then ultimately at that next hop, you can actually see that change. Again, by looking at this from an interface perspective, we have really granular views. And again, we're talking 1 minute, so we have as granular as flow can be and as granular as an observation point can be. We can see at every hop in its path if there was some sort of transformation made to the packet. A great way for validating DSCP schemas and making sure that your intended markings are showing up at the segments of the network that you'd expect them to be. So for workflows like that, when we start with all of our interfaces here, we can go up to our filter icon and actually work in the interfaces. So if we have a series of interfaces that are WAN interfaces and kind of the SNMP name, all of this information scraped through SNMP. So again, you just set up a device to export to us, and then we'll just start pulling it for SNMP things to actually learn what are these interfaces, what are they called. So that way there's really no guessing as to like, what does this index represent exactly? We can work in kind of the names we're used to. But in this case, we can search our interfaces for just our WAN interfaces. And then once we have our kind of subset of interfaces there, we can actually pivot into a report that will use all of those interfaces as our input domain. So that was kind of the first slide of the slide deck area, was really being considerate of input domains and where are we sourcing data from at any point in time for what we're looking at. Having one place where all of your various inputs are being fed makes this really nice because you can move pretty quickly between them. And then again, ultimately, the analytics stack that's going to review all the data has all of the input data from the entire network to review. We've selected our WAN interfaces. We can click on into reports. Again, we'll look at some more interesting ones. Anytime you're in the product, if you're pretty green to flow or green to the product, a great place to start will be our pair reports, conversation by app. This will give you a very kind of standard NetFlow view where you've got that basic 5-tuple of source, destination, port, and protocol, and then ultimately some collected metrics against those, in this case, bytes and packets. And that gives us just a way of kind of quickly moving over and getting an idea of, what hosts are using which applications on our WAN interfaces in this case, because that's where we started. We started with our interface list, filtered down to just the WAN interfaces, and then pivoted over into actually what is the content of the traffic that those interfaces are handling. Starts at a pretty high level. It's pretty verbose, lots of entries. There's lots of other ways to summarize these things. At any point in time, when you're working in reports in the product, our filtration stack is actually going to follow us from step to step. So if we want to change report types to look at the data kind of cut up in a different way, but we've already applied some filtration, that's perfect. That will hang on and follow us, even if it's not a field that's necessarily explicitly in the next report. As an example, we see a lot of this SRV finance host that's participating in conversations here. If we actually wanted to grab this and bring it into the include section of our filter tray, we can see that adds a filter for that host in both kind of directions of the conversation, whether it's the source or destination, and we can reapply. So without changing the report type, it's pretty reductive because this is what we were already looking at. We basically filtered on a quantity that we could already see in here. But with that filter applied, we can actually now change our report type and look at something that's very basic, like just our application definitions, because we have carried over this idea that this very busy host on the WAN we brought as a filter, so we know all the conversations that we're looking at have this host participating in them. And now we're purely looking at the applications, and we can see that just this financials application is really the only component that that host is handling. This financials application is actually a great example of enrichment on the platform. So if we were to run this in just like a well-known port type of view where we're not imputing our kind of local application destinations or definitions, we can see this is just kind of HTTPS 443 TCP. So just generic transport, really difficult to tell this apart from just kind of basic web browsing traffic all the way through data transfers and more as time goes on. A lot of things by the day seem to just get further and further encapsulated in HTTPS. From this type of view, again, we know our context still. We picked our WAN links. We filtered down to the busiest host utilizing the WAN links. We took a look at the application. We saw it was our financial application. But if we didn't have that definition in there, we can see from this perspective that it would just be kind of this generic 443 TCP traffic. So this gets interesting in the sense that when we come into admin and definitions, where we can actually define the things that are unique to our environment, we can go into our application view and actually see what that financial thing represents. In the case of your own environment, you already know that'd be kind of the those buzzwords within the NOC or SOC of applications that you hear about on a regular basis. But from this perspective, we can see that financials is going to be TCP 443 for some specific IP addresses. And in this case, we can see that IP address we were filtering on in our example report is actually one of those. Again, it gives us a great idea where for generic traffic, this would just be HTTP 443, but specifically when it's HTTP 443 being handled by that host we filtered on, the platform knows that this is the financial application. So again, if that's where we're investigating is application degradation along the lines of that specific application, we now have a pivot where we can go in, just look specifically at this financials view and get an idea of when it's being used over kind of whatever portion of the network it's an issue. Again, in this case, we filtered down specifically to WAN. So in the cases where we have less information, right? So maybe this is not an active incident. This is something that was reported previously. And one of the biggest struggles of those scenarios can always be trying to replicate the actual network environment at the time when the incident was reported. So in this case, we might know what devices are involved, if it's a specific firewall that's kind of the topic of conversation, or maybe we only know things about the content of the traffic themselves. So on the platform, when we click into Run Report, we have two options. The one on the left here is going to be selecting devices. Again, the case where we know the actual network infrastructure that we want to investigate, or just selecting report types where we're going to work more in the content of the traffic. In that case, if we wanted to go to select report type, we get a view of kind of our recently used reports and recommended, and then ultimately a big list of all the high-level categories that we can report around. So each of these will have a subset of views inside of them. So firewall events example, there's a few different ways of cutting that data up. But what's really powerful is, and going back to when we were talking about IPFIX and the template structure in the slide deck, the platform reads the templates in, understands what information elements we can use, and then dynamically will change what's available for reports to the user. You'll really never be presented with something that you don't have data for. And it will also just give you a great view at this kind of high level of reporting as to what types of vendor support or, again, those exotic information elements you actually do have availability to, and new workflows that you can kind of leverage because they're present. We think about something like Palo Alto devices. Palo Alto devices are very strong exporting devices. They can go through and label everything very explicitly with applications using the DPI engine that's in the Palo Altos themselves that it's going to use for traffic inspection in the first place, as well as username export. In the case that you're, maybe terminating a VPN with the firewall, it has an idea of what user is attributed to that traffic, and it can export that in the flow data. So if we go through and just quickly look at what that looks like, we can take that firewall, get an idea of who the users are. Again, these could be people or service accounts. Who's using what at what point in time. So if the event that we're investigating is attributed to the report of a specific user, we can actually take a device like this because it has that information, start from the perspective of that user, maybe this Allen Brand, click into them, and then just like the IP addresses in the previous view, we can actually use this user now to pivot between other data. So if we want to see, exactly what type of flow data is attributed to this user, we can use our pretty standard conversation by app report again, that basic NetFlow view. But again, this time with kind of the background understanding that all of these flows are being attributed to this specific user, even when they're not necessarily, active and present in the conversation. So then finally, one kind of interesting view is going into our IP group definitions. From the IP group definitions, we, again, understand kind of the functional usage of the different IP addresses and subnets on the network. And we can start our reports from that perspective. At a very high level here, I'll go into our pair reports and IP groups with applications defined. And I'll grab just our firewall devices again and move those over, and then run the report. And now this will actually give us a view, and I'll change our graph type to something like Sankey that better represents kind of flow between nodes. And from this view here, we can immediately get a high-level view for our firewalls that we used as our input domain. We have the visibility into now what applications are being handled, but additionally, what functional centers of the business are those applications moving between. In the case that you need to investigate a problem that's affecting a specific vertical of the business, we can always filter down to something like this NYC data center and make sure that's either the source or destination of conversation and reapply. And again, that'll filter out all the results that aren't specific to this one node here. As again, we can see it as both a source and destination on each side. Once we've kind of filtered down to the content that we're looking for our root cause analysis workflows, we can go back to a temporal view. So something like the line view that will show us usage over time. At this point, we can go in, we can kind of see when there's spikes of usage, when there's pretty big lulls in usage. And this is really where we pivot back to the idea of our granularity and preserving all the different levels while still making the aggregates. So right now we're working at 2-hour intervals, so we can move really quickly, look across really wide frames of time. But as we click and grab sections of the graph, this spike in activity, we can actually drill in. We are now down in 30-minute intervals, so we have a great idea of kind of what's going on, again, over these still wider time frames. We're looking at about a day of data in this case. And then we can further go down right into these peak values. and continue to move into more and more granular data until we're actually working against kind of the atomic level flow records themselves. By kind of using this method, we can visually identify where the spikes in utilization are. Through using kind of the enrichment components like IP groups, we can understand kind of what function of the business is impacted at these points of time, what applications that are maybe unique to us are impacted at this time, and then ultimately drill down into these lower level views. Once we get into these lower level views, I'm just going to keep us on one firewall for a moment. We can actually pivot all the way through to a raw flow view. So this actually gets us all the way back to the records exactly as they were exported from the original exporting device themselves. We can go all the way from our super wide time frames of over the last day, when is this device the busiest, or when is this network segment the busiest, drill down, find those spikes kind of through that graph navigation, and then ultimately land on the raw records as they were produced by the device. So these will be the, kind of the actual evidentiary components of supporting kind of the result of your investigation, all the way down to actually pulling these records, seeing things like class of service on them, and having an idea as to what or where in the network, rather, those mutations may have occurred. All right, everyone. So again, thank you very much for joining today. This is kind of a high-level overview just around some of how we think about flow data on the platform, how we interact with it, and then ultimately how you can kind of very quickly navigate through those really wide time frames, keeping in mind things like the actual function of a device on the network, what application it's handling, and then drilling all the way down to the really low-level atomic records that can prove out exactly what was occurring. Again, thank you for joining us today. The next one of these talks, No More Act Faster, Enriching Your Network Ecosystem with Smarter NPMD, will be on Tuesday, October 14th, the same time, same place. We look forward to seeing you there. So thank you very much.
Yep. Great job, Adam. Thanks all for joining us. And if you haven't already, you can follow us on the socials at Plixer, on Twitter at Plixer1, on YouTube, the Plixer account, the showcase account on LinkedIn. And now we have a Reddit spot. So if you have any questions pertaining to observability, NetFlow, IPFIX, any Plixer solution, you can go to r/Plixer1 and drop your question in there. Appreciate all of you joining. For my good pal, Adam, I'm Peter, and we're with Plixer. Thanks for watching.
Thank you.